you do damage to the nervous system, no question about it. So that is sort of the consequence of bathing your brain with sustained levels of cortisol for long durations of time.
This is Zen-Brain. We throw around the word stress ever so casually, but what exactly is stress? Stress could be defined as our body's reaction to a challenge that we are faced with, danger or a deadline. And in fact, occasional stress is good. Many people seem to thrive in it. But if it's daily and it's bad stress, it could be bad for our health. Joining me on Zen-Brain today is neuroscientist and Professor Vidita Vaidya from Tata Institute of Fundamental Research, or TIFR, Mumbai. Vidita studies the neurocircuits that regulate emotion and how changes in our brain circuits form the basis of psychiatric disorders like depression, and how early life experiences contribute to persistent alterations in our behavior. What led us to Vidita, however, is her interest and research in understanding this whole concept of stress and the science behind it. What happens to our body and brain when we are stressed? And how is it that some of us develop resilience to it, while some of us become extremely vulnerable and overwhelmed because of it? Some people even fall physically ill due to stress. Her lab work is conducted on lab rats and mice, but do human beings show some of the same traits as well? Well, let's find out. First of all, thank you, Vidita, for joining me on Zen-Brain.
Thanks, Shruti. It's a pleasure to be here.
Very, very basic question. Tell us what stress is really, good stress and bad, and the science behind it.
It's actually, stress is difficult for anyone to define. It doesn't matter if you catch a person on the street and ask them, what is stress? People will struggle to come up with a good definition of it. That's not only true for a layperson, it's also true for a neurobiologist, because stress is still a fairly difficult and complex term, even for someone who studies it for a living, right? Partly because there's a catch-all term like stress, and yet your stress and my stress may be utterly different. A simple way of thinking about it is, let's take some entertainment like bungee jumping. Right? There are people who do this for a living or for joy or pleasure or entertainment. They tie a rope around their ankles and they jump off bridges. And this is a big high. Now, if you were to ask me to do something, or I don't know if this is true for you also, Shruti, but this would be a horribly stressful experience for me. I would not find this remotely close to entertainment. And that itself tells you that just something that is stressful for one person may be actually entertainment for somebody else. So in some sense, stress is individually experienced, but it can be defined as something that challenges your body's balance. And what do I mean by balance? Balance is metabolic balance. So someone who has diabetes, if their blood sugar goes haywire, that's obviously a disruption of maintaining of their sugar levels, right? Much the same way, your body has many processes that are maintained under a pretty tight balance. Your temperature is regulated. Your body's ability to secrete hormones is under regulation. There's a diurnal rhythm. There's a morning and night. We respond to specific rhythms in the day. And all of these things are, your hormonal systems, your biochemical pathways, all of these things are in a certain state of balance. That's also true for your brain, which is, by the way, eventually regulating a lot of things in your body. And things that disrupt balance or things that mess up balance can then be defined as stress. And that's why you can see why this is such a difficult term to define, because what disrupts my balance may not always disrupt your balance. So something like cold temperature can also be a physiological stress. So if you and I suddenly travel to the Arctic and sit out there, and while it might be a jolly trip where we are imagining, oh my gosh, we get to go to Siberia or Arctic, in the freezing cold, your body will be under cold stress if you're not well prepared for it. But if you're nicely bundled up and you've worn all your appropriate thermals and you're sitting there, then you're not going to be challenged the same way. So the reason I'm giving you this broad, vague definition is it is vague. It's highly variant depending on the set of circumstances, upon the set of situations. And so anything that disrupts your homeostatic balance would be defined as a stressful situation. I know that gives you a sense of how vague that definition is, right? It's pretty broad. Yeah, it's pretty broad.
No, we get it because, but I want to specify here, this balance that you're talking about, this balance could also vary, right? My balance could be very, very different from your balance, right?
I mean, it depends on what you. No, that's not true. So, for example, let's just look at something as simple as thermoregulation. Your thermoregulation and my thermoregulation pathways are going to be pretty similar, right? And when we end up mounting a fight against a virus or a fight against bacteria, the reason we raise our body temperature is because that's part of the immune response that is attempting to tackle a challenge to the body, which is an infection. In that sense, it's pretty conserved. So for your physiological systems, for your ability to thermoregulate, for your ability to manage your blood sugar, the pathways are pretty conserved and pretty similar. Now, when you talk about things that disrupt your psychological state, that could be quite distinct because it would be a different trigger. Your responses and your responses of your body could be similar, but the triggers could be different. So in that sense, I think what we have to understand is the external triggers can vary. The internal responses are actually remarkably conserved. They are conserved in rats, mice, monkeys, humans. We use very similar pathways to cope with stress. But what is going to trigger the stress response can vary.
So how much do you think our response to stress has changed as we have evolved as a species?
I don't think it's drastically changed. The pathways are actually fairly conserved. And we developed a really beautiful physiological stress response system. And that's held us in really great strength. For all vertebrate mammals, there's a very common pathway that is evoked in response to stress. But perhaps what has changed is the complexity of our worlds outside. So the triggers that drive those stress responses have now become completely different, and they have moved much faster than the evolutionary time scale. So the world we live in today is very different from the world 100 years ago or 500 years ago, and certainly 1,000 and 10,000 years ago. But in terms of the pathways, if you took a human being from 10,000 years ago and you took one of us and say, what's the stress response? That's not changed on that time scale at all. It's very similar. Yeah, there will be minor changes, individual to individual variation. But overall, if you say, do we use similar systems? Absolutely. We use similar systems like our primate ancestors or our primate cousins do. We use similar systems that are rodent sort of common lineages where we would have common evolutionary lineage. This is quite beautifully conserved. So in that, it's not very different. But like I said, what triggers the response externally has changed drastically.
Absolutely. You're so right when you say triggers have perhaps changed for all of us ever since our hunter-gatherer ancestors, right? Let's talk about that a little. Stress is good. We were evolved as a species to be stressed sometimes, yes. Right? But when Absolutely. Is it bad? When is it bad for health?
It's really good. Like, let's say you and I go for, whatever. We decide we're going for a walk in the middle of a field and we're enjoying ourselves, a beautiful birds twittering along, etc. And suddenly a big cat shows up. Okay. Now, at that moment, you and I are going to mount an insane stress response. And at that moment in time, to survive, hopefully the cat doesn't eat us and we don't become prey. We find a way to save ourselves. We're going to have to, there's no fight. We have the capacity cognitively to realize that fight is not going to be a good situation here. Flight is clearly the right approach. So run as fast as you can to whatever, you create a huge noise and get somewhere either up a tree or to some safety or some shelter, right? But to do that, you're going to have to mobilize an insane amount of glucose to your muscle at that moment in time, because your muscles are going to have to function at optimal capacity, right? So now you imagine that. So what would a stress hormone do? It's going to redirect glucose in your body. It's going to send it to the muscles. It's not going to send it to your digestive tract. So even though if we had gone for a breakfast walk and we have eaten a nice, whatever, dosa or whatever, at that point in time, you don't want to worry about digesting your dosa. Absolutely not, right? You better leave it for, if you survive, then you can digest your dosa. So at that moment in time, you shut down digestive pathways, you shut down reproductive pathways, make no sense in that moment. So you shut off reproductive hormonal control, you shut off digestive pathways, you will mobilize glucose to your muscles, you will mobilize your defense pathways. So your immune system cells that are surveillance cells that hang below your skin, etc., are going to all be on go just in case you get scratched, bitten, attacked. We have to handle a wound, open wound. So, you are moving your body into, all the things in your body are moving to survival, quick survival mode, right? And all the things that are slow growth, like, growth is not going to be a worry, reproduction, digestion, all that you can do another day. So this is beautiful because yes, it gives you a fighting chance. If you have any chance of running away from that big cat, and if you make a lot of noise and you manage to survive, you have survived to live another day. Now, this is great. Now, let's change the scenario. Okay, we'll change the scenario. You and I are going into an office situation. We are friends, we go into an office, and now we don't have a big cat, but we have a boss. And the boss walks into the room, and the boss has been really nasty about deadlines, has been really, denigrated our performance, made us feel terrible about ourselves, etc. And there we are sitting, and in walks this boss, and this boss says nothing as innocuous, or just something so innocuous as, hello, what are your plans for today? Now that sentence is not a terribly loaded sentence, but if you have a history with this human being where for months this person, that what are your plans for today, triggers this whole performance appraisal and worry about, you and I are going to mount the same stress response. Nothing different. Our digestion will shut down. Our reproductive pathways will shut down. We will mobilize glucose to our muscles. Our heart rate will go up. Visceral pathways will be modified. So many things will change. It's the same response pathway, except that in that situation, there was a survival situation from that tiger and it was over. Here you have this situation where this person is going to be in your life every single day. And if you do this every single day and shut off your digestion and can't have an undigested meal floating around in your tummy, your hormonal pathway shut off, you can imagine the cost on our bodies if we are mounting this kind of a response in a situation we actually there's not a big cat or any such thing. So this is where I want you to just imagine that the triggers have varied, but our responses are so conserved. And if you do this chronically over long periods of time, this is chronic psychological and psychosocial stress. And that can do a real number on your body and your brain.
In a situation of bad stress, which is there perhaps even daily, and we know of so many people who still continue to go through it on a daily basis, what happens to them?
So here's the thing. These systems were beautifully designed for short-term, quick usage. Okay. They were designed for that. I mean, now let's imagine our hunter-gatherer 20,000 years ago, right? It was beautifully designed for the situation in which you had to go get food or you had to prevent yourself from becoming somebody else's food. These kinds of situations, the system is perfect. It's short-lived, it's quick, it's over. There's a termination clause. So the stress response pathway, which we all label as this awful pathway, is actually phenomenal. I mean, it gives you this incredible ability to mount a quick, fast response and you recover and you're back to baseline. A problem happens when you do this repeatedly over a period of time and you don't come back to baseline the same way. In fact, because you're doing it so often and so many times, sustainedly, your body is now getting bathed with these stress hormones at higher levels than it should be. And as a consequence, you have many things that happen. I mean, let me just give you the names of a few of the kinds of critical disorders that affect our generation, but were not the main disorders of, like, say, 200, 300 years ago. Cardiovascular disease, hypertension, irritable bowel syndrome, reproductive challenges in terms of infertility-related issues, the polycystic ovarian syndrome, diabetes. Look at each of these disorders and the critical factors that exacerbate and in some cases precipitate our stress. I have not even yet opened up disorders of the nervous system that include the entire gamut of psychiatric disorders, anxiety, obsessive compulsive disorder, bipolar disorder, schizophrenia, all worsened, definitely worsened, in some cases precipitated major depression and anxiety, stress plays almost a precipitating role. Certainly plays an exacerbating role, but precipitating also. So when you look at the kind of diseases that our generation is plagued by, you realize that a pathway that was meant for our survival has gotten hijacked by life now to be used in a way that's perhaps inappropriate. And we don't shut down these pathways fast enough. And when you bathe your body chronically with cortisol, which is the main stress hormone, which is lifesaver, but if you're bathing your body with it all the time, then you are doing steroid related damage to multiple parts of your body, including your brain. I'll use the brain as an example, but the one big thing that happens is neurons in the brain like a low dose appropriate amount of cortisol, but when you bathe it with high doses of cortisol, neurons don't like it at all. They become much more vulnerable. Plasticity related changes, the capacity to quickly adapt is really dampened. Over a period of time, if it's very long duration, you will kill populations of neurons. There are neurons that are vulnerable to it, and you do damage to the nervous system, no question about it. So that is sort of the consequence of bathing your brain with sustained levels of cortisol for long durations of time. And I want you to understand that this is a powerful system and a beautiful system, in that when used appropriately and quickly, it really allows us to survive and buffer incredible challenges. When inappropriate, it can really hijack. Yeah, it gets hijacked and it can cause disease.
Yeah, I mean, it's a very, very interesting point that you're making. And I hope people who go through chronic stress are listening to this, because it is damaging their body. And this is a very important takeaway from whatever you've told us about, like not just physical, but there is psychological precipitation of diseases that we don't really link to stress, right? We use the word so casually.
Yeah, sometimes we don't. Yeah. Yes. I mean, unfortunately, in our society, we tend to, anyone who collapses under stress, we tend to blame the individual, which is a really unfortunate way of looking at, we expect individuals to surmount gargantuan challenges rather than realizing that sometimes some challenges are so large, they may not be easy for a human to navigate.
Mm-hmm. Let's talk about cortisol a bit, because it keeps coming up in discussions. Very simply put, right? Cortisol is released when we are under stress, right?
Absolutely.
However, what happens?
Not only under stress, every day. So we have a diurnal variation. So we are awake during the day and at night we sleep, right? So we have a nice morning peak of cortisol because there is an AM, PM. At night, you go back down. Morning, you have a nice cortisol peak. So there's always been a natural variation also. That also goes haywire if you don't follow the diurnal clock. So that itself can be a stressor. If you stay up the whole night once, it's okay. Twice. If you're doing it all the time and not getting enough sleep, sleep deprivation is a stress as well. And that will disrupt your diurnal rhythm, which is your natural rhythm of cortisol. But yes, excessive release will happen when you are mounting a response to a specific challenge. And that can be anything. It can be a physiological challenge like an infection. It could be temperature. It could be a cut or a wound. It could be, a disease or an illness. And cortisol is your attempt to try to help your body to cope. It can also be somebody yelled at you. It can also be a fractious relationship between two individuals. It can be many things. So it's psychological, physical triggers will both do it.
Mm-hmm. Let's talk about sleep a bit. Sleep deprivation, sleep alteration cycles. I think a lot of people live against the circadian rhythm these days, right? And you said once or twice is okay. But what does it do to the body in the long term?
It does a number. It does quite a number. I mean, it does a number to your baseline ability. See, you have a nice diurnal variation of cortisol, and that is a beautifully tuned system. And that tuning is very important for what your body is doing on a daily basis. We are a species that programs ourselves based on our light, dark periods. Now, if you totally mess up the light and dark period utterly, then yeah, you have a free running circadian clock a little bit, but this is going to go haywire. And Yeah, I mean, I think sleep deprivation is a cause of a whole bunch of things people are utterly unaware of, because it's a driver for, in itself, sleep deprivation is a driver for causing long-term damage to circuits in the brain, to physiological pathways in the body. And chronic sleep deprivation is a big trigger of a whole bunch of other things. So yeah, it also changes your ability to, why do we always say have a good night's rest and then tackle whatever you have to tackle, right? Why is this is like this grandmother's tale, and we always say, oh, some grandmother told you go have a good day. But it actually is not a bad suggestion at all, because very often after a good night's rest you make more rational, practical, sensible choices, decisions, because you had a chance for your brain, in a sense, to have that shutdown time, your body to have that shutdown time and rest. And then you come back and you can tackle whatever it is with a greater capacity.
Mm.
And the same problem that was bothering you at 2:30 at night may not seem the same at 8:30 in the morning.
Usually never does.
Absolutely. Absolutely.
But that brings me to another point now. How is it that different individuals handle or cope with stress very, very differently, even amongst siblings? How is the response system so different?
So think about it like this, like in its blueprint, it's the same. Okay. You have a hypothalamus, which sits at the base of your brain, which regulates this thing that's dangling off of it through a pituitary stalk. There's a little pituitary that will secrete a bunch of hormones that go into your bloodstream. And eventually your cortisol is produced by your adrenal glands, which sit on top of your kidneys, right? So on either side, you have the adrenal glands bilaterally. And that's where the adrenal cortex produces cortisol, which is derived from cholesterol. So it's a lipid derived molecule. And then it goes into your bloodstream and goes everywhere in your body. And all cells have the capacity of responding to it. So this basic program is there in all of us, right? So it's not as though you and I don't, we both have it. Now let's imagine that, okay, let's take a simple difference. Okay, let's take two kids. Both of them have grown up in the same household, whatever. And they generally had similar broad environments, things. Genetically, there will be similarities. Then let's imagine that they go to school and they take a math exam. Okay. And they have some two different teachers. For one child, math becomes fun and play. For the other child, math becomes torture. Okay. And you will find plenty of people who you will ask, what do you feel when you have to take a math exam? And you will see two different, you see the spectrum of responses, but you can get two different extremes. Kids who hate it and kids who are like, math is so easy, so fantastic, so smooth, so simple. I love it. It's beautiful. It's so easy to do, right? And in these two examples, you can see why an environmental programming can change how that pathway will respond. For most individuals, if you want to measure their salivary cortisol, you make them do rapid math calculations, rapid. And then you take their saliva and measure the cortisol, and within 15-20 minutes, you will get a nice cortisol peak. Because for most people, doing rapid mental math is a stress. Okay. And you will get a nice cortisol peak, and you can actually do this experiment and see that the salivary cortisol clearly goes up. For some individuals, it goes into the zone where it is traumatic because it brings back so many memories of perhaps poor performance, but that performance is not just stopping in failing an exam or getting a C grade or a D grade. That D grade evokes memories of disappointment, of not having fulfilled expectations, of then become somebody who you predict, this one will never do well. They could not even manage their 5th standard math exam. So, these things that are made about predictive statements are made about children. And then that carries a scar, which can be seen in a 60-year-old. Why should a 50-year-old have a salivary cortisol response to mental math? Frankly, it's not going to change anything drastically. You're no longer doing some entrance exam, some exam, whatever. But for us, it's the evoking of all those events associated with it. I gave you the example of a math example, but it can be anything in life. That it's these triggers and associations, and they get built very, very early. That first decade, that first 15 years of life shapes how you will use this stress response pathway. There's something called a stress hypo-responsive period. It's an early window in which this system is tuning itself, right? It's preparing for the future. Hopefully, the view at that point is that somebody else will protect you. So when you're that vulnerable, your protection is coming from those who are protected. But if nobody protects you And if you have adversity, then your pathways are also going to be programmed slightly differently. Now, I don't want you to walk away with the feeling that if you had an early trauma and if you had early adversity, automatically you will be bad at coping with stress, because that is not true. Okay, that's not true. There is profound individual variation. You have stories of people who surmount incredible early life challenges and manage to cope. But there is a combination of genetics, environment, set of life circumstances, and it's not just one window, it's windows. So there's the early childhood, there's adolescence, then there is sort of the early 20s. Life events here have a profound impact on how the system will tune itself and respond in the long run. And so, yes, it's true, what you do in that first window of life, the 15-20 year window, the first decade being absolutely crucial, shapes the responses. And at that point in time, sometimes you can say, why two siblings and why are siblings so different? But the siblings have not had an identical experience even in utero. And even twins don't have identical experiences in utero, because already there is a variation. Sometimes identical twins, you see this one has thrived and been big and the other one was small. Why? Because the distribution of nutritional resources sometimes is different. You cannot say it's an identical in utero environment. Certainly for siblings, it's not been an identical even outside the uterus once they're born. The parents are not the same. The parents who parented one child are not the parents who parent a second, because their parenting styles change, their life experiences change, their world may be different. And so, yeah, absolutely, it can be very, very different even between siblings.
Tell us about early maternal attachment, because that is something that you've done experiments in, right? Tell us a little bit about that.
So I would say that because I work with species where there's only the maternal caregiver, I bring in the maternal component because I work with rats and mice, and there in many cases, it's not a biparental system. I want to caveat this at the very beginning and say that in primate species, it's caregivers. And it's a much broader world. So you will see this with monkeys. I mean, the best example of this is when you look at a bunch of, langurs, macaques out in the wild. Many of us, when we are driving, have gone to the ghats and we see these tribes of monkeys, and you see the babies in those tribes and you see how they distribute between multiple different. So there's the mother, there's the aunts, there's the uncles, there's the siblings, there's the cousins, there's a whole social milieu around that infant that is being raised, right? The reason I talk about maternal components strongly is because the species I study, there's a very short-lived window. There's about 3 to 4 weeks in a nest with a mother, largely doing most of the caregiving. But I want to caveat it that those studies tell us about maternal attachment, but the minute you move to primate societies, it becomes way more complex and there are way more caregivers. It's a much more complex caregiving society. So I will say that rather than using maternal, I would say caregiving is an essential component of the early priming of these stress response pathways. Touch being perhaps the central driver, but so is smell, so is voice. A child is bathed with auditory experiences 5 months onwards in utero, and those auditory experiences are part of that environment even in utero, much the same way the diet certainly is. But when you emerge out, the reason why we talk about huddling and cuddling and swaddling the child and the touch is a big programmer of responses for that infant. And the priming of that stress response pathway, the ability of the stress response pathway to actually get optimally functional does depend heavily on quality of care. And in complex societies like ours, where there are so many multiple caregivers, caregiving can come from parents, can come from aunts, uncles, grandparents, can sometimes come from so I would give you a great example of adoption, where we've seen young children adopted, taken over by a family that adopts. The profound caregiving that is given there can buffer sometimes the stresses. A child left at an orphanage may have had challenges already in utero and even post-birth, but we've seen such profound impact. And when I say we, I mean the community of those who do research on this can see the profound impact of adoption. So caregiving, I would say, is the primary driver. in a child's life in that first 5 to 10 years, 5 years being absolutely central in shaping the way they will respond for decades and decades later. So yeah, it is profoundly important. I think it is singularly the most important thing as a society we as human beings can do.
So one of
And
the
it's
things,
unfortunately the most ignored, sometimes the most ignored. Yeah.
It is indeed. I don't think we thought about it, but perhaps the first conversation that we had, something stayed with me about what we talked about. The feeding process itself between two
Yeah.
mothers, the difference, and how that
Yeah, so,
impacted.
yeah, so this is studies that have been done from Michael Meaney's lab, which is at McGill, and they were really profoundly important studies and informed the field a lot about how variations in maternal care can also have a profound impact. So he was just observing rats and looking at how they caregive, and there are a variety of modes of caregiving. And what he noticed were that you had a distribution, but at the two ends of the distribution, you had two interesting observations. You had a caregiving model where the mother sat literally almost arched back over her pups and was constantly licking and grooming them as they were nursing. Very active nurture going on. And at the other end, which is the other extreme, so we're looking at two extremes and many in the middle. But the two extremes, the other extreme was a very passive mode where the mother lay on her side, so the pups were still nursing, but there was no active licking, grooming, touching. All of that was a little bit dampened on this end. And then when he followed the progeny of these two, so over time, he noticed interesting differences in their stress response pathways. So the pathways of the animals that were born to very high caregivers, right? High amount of caregiving. And actually, they were not nutritionally different. It was just the nature of care was a little bit different. The naturally occurring high caregivers tended to have animals who had very beautifully primed stress response pathways. They would give a nice response and come back to baseline very quickly. And so they gave the response, but it was very nicely tuned. The ones at the other end also gave a stress response, but the tuning of that was not as good. And so what would happen is, while you would have the same peak, to return to baseline, you would return much slower. So what happens when you take time to come back to baseline is that the body is bathed with much, in the case of rats, it's corticosterone instead of cortisol, slight variation in the hormone. You just end up having it for much more longer. And what ends up happening then is, now you imagine this system. You have a stress response that's really super fast, programmed, quick up, quick down, beautiful. This is up, but then doesn't come back down for long durations. And you end up now making multiple organ systems, including the brain, way more vulnerable to chronically being bathed with these hormones for longer. And these animals now show behavioral differences. The animals on the right hand side, the high caregiver ones, have lower anxiety, lower despair like behavior, enhanced cognitive performance, altered stress priming pathways, and immune responses are different. This end is much more anxious, much more despair like behavior. So there was a correlation. And so then he got really interested. It's like, oh, this is really interesting. So now suppose you take the animals who are at this end, who are born to, is it something that has happened across generations that is genetic? It's not. It's environmental. Because you can take this bunch and start giving them high care and everything moves. And you can take the bunch that had high care and give them low care instead, and again it goes. So it is something that is primed by the environmental care, the quality of care. And that quality of care is not some genetically determined thing. It's the experience you get in that window. And that stays with you for decades and decades. And not only does it stay with you, it also programs the quality of care you give. So again, coming from the Meaney lab, beautiful work that shows that the kind of caregiver you become is often programmed by the kind of care you are given. This is in rodent models, but it's not very surprising to see that there is components of this that can also extend over to primates and to humans, that the nature of care you give determines the nature of care you will provide.
Wow.
Right? What you receive defines in many ways what you go on to give. And so this becomes very, very interesting because you can steepen now. And then now you start imagining this. You overlay on this economic hardship, nutritional deprivation, And you can just imagine that the consequences of this are so long. So sometimes we say we forget the privileges we carry, but the privileges we carry are sometimes given to us by generations and generations. And then we say that everything that comes our way is because of our merit and our capability. And sometimes we just forget that no, it's where we were and what we got. And we got so much privilege. And then now to deny that opportunity and privilege to someone who has for generations been deprived. I think that insight, if one had as a society, one would see things so differently. But sometimes you're dealing with individuals who have had generations of deprivation. You really need to provide way more to provide equity. It's not equality, it's about equity, right? At some fundamental level, everybody is equal. It's not equal. You didn't start equal. We've already been given a fighting advantages, such large fighting advantages. So for equity to happen, you're going to have to really rethink and relook at society at large if you genuinely want to provide equity. Yeah.
I think whatever you've said is profound, and I hope people take away all the nuggets of wisdom that you've given us today. Caregiving at any point in life can change anyone, right?
Hugely. I mean, there was this very unfortunate set of situations that arose in Romania during the entire period of the Cold War, etc., where there was, there were a lot of children put in orphanages where they were deprived not of food. So actually, nutritionally, they were not deprived, but they were really deprived of touch and caregiving. And these children actually developed a condition called stress dwarfism. And that's because the growth hormone pathways that are required for your normal full growth to take place are also impacted by stress hormones. So when you have very high levels of stress hormones like cortisol, you actually shut down growth hormone secretion. And by doing that, you stunt these children. So they were stunted. And it's the most extreme form of what caregiving deprivation can do, which is stunting and dwarfism. And now you think about it, you say, but this is not a genetic dwarfism. This is an environmentally induced dwarfism because of the trauma and stress of that early window. And then these children were adopted. Sometimes they were adopted at different times. And the ones who were adopted relatively early, you could just suddenly see this spurt of growth. And that was dramatic because you're thinking, here's this child who's come with a growth retardation and a growth slowing and stunting. And here comes in care, quality care, and you see this drastic difference. And you just see, my goodness, what environment and experience can profoundly do. And then if you saw adoption after these windows that are called critical period windows, the critical period window was shutting, and that child is now stunted for life. So is dwarfed for life. And then you think about our society's responsibilities collectively, and those we abandon when we as a society choose to turn a blind eye, right? And then as a collective, what is our responsibility? We have individual responsibilities, but we have collective responsibilities as well. It's something to really ponder upon. And I really feel that if as society, our emphasis is on that first decade and first 15 years, what we do with the midday meal, with providing nutrition, providing care and support, providing Anganwadi caregivers, a variety of ways in which there can be interventional approaches. You are worrying about the economic progress of our country. You do this, the economic progress will take care of itself, because we are a very young country, supremely young country. The future of the youth is going to emerge from India. I mean, we are 1/6 of the world's population and we are very lopsidedly young. If you don't do this right, you seed public health disasters in the long term. You seed a country which will have high degree of stress-associated cardiovascular disorder, metabolic disorder, anxiety, depression, a variety of psychiatric, because you're seeding the sort of substratum on which these diseases will eventually emerge. They don't emerge immediately, they emerge much later, but you provided the sort of substratum. You do this right, the public health consequences of this you will benefit from 20, 30 years later, but they will emerge, no question about it, because that first decade, right? I mean, it's a definer of, in many ways, the rest of life.
So true. Let me ask you about your research. What have been some of the key learnings for you where stress is concerned? And even if you've conducted them on rats and mice, what have been your greatest learnings?
I think perhaps I underappreciated, even as being a stress researcher, a neurobiologist who studies circuits in the brain that regulate stress. Even I was amazed and blown away by the long-term impact of fairly short-lived early trauma. I didn't anticipate the scale of it. And that in some ways has perhaps made me want to do as much outreach and talking about this, because I think, oh my God, I had no clue. Rats have a relatively shorter lifespan. It's 2 to 3 years. And what we do is fairly mild perturbations in the first few weeks of life after they are born, where we perturb their interactions with their dam. And their primary caregivers, only the dam. There's nobody else in that situation. And because we do a perturbation that deteriorates the quality of care, they're nutritionally not at all deprived. Everything else is the same, but the quality of care they received deteriorates in that first 2 weeks of life. And we see that these animals have effects 2.5 years. 2.5 years later, we can tell which animals had that early history, because they show an accelerated aging like phenotype. They have peripheral inflammation, they have central inflammation, they show telomere shortening, which is a marker of how you age. This has also been shown in humans who have early adversity, the telomere, which is the ends of the sort of chromosomes that actually erodes anyway naturally with age, but it erodes much faster in individuals with early trauma and early adversity. And we see this in our rodent models. We see profound changes within the brain, indicating central inflammation. We see reduction of stem cells in the brain that are involved in repair. We see cognitive disturbances, anxiety, despair, the hallmark signatures. And this is after a short-lived experience that was in early life, and we're looking 2.5 years later. So perhaps I didn't anticipate that the persistence of impact is so long-lived. I'm equally pleasantly surprised by how it is possible to reverse it. And that gives me hope that it's not all set in stone, and that it's not all like written in your, like they say, it's written in your stars. It's not all written and done. It's reversible. And that gives me immense hope that, enriched environments do it, certain nutritional supplements and interventions do it, pharmacological agents do it, caregiving in the early juvenile window can compensate for things that went wrong early. So, things reverse it. They may not reverse everything, they may reverse aspects, but it is in principle more possible to go in and intervene and change it. And you have long windows in which to go in and intervene. And so that, I think, is perhaps the greatest sort of learning I'm getting from animal models. And I'm thinking, oh my gosh, you can do all these with rats and mice. Less complex societal structure, certainly in a laboratory environment. In the real world with primates and humans, much more complex interactions, way more complexity, but that gives you so many possibilities of reversing. Wow. So yeah, it's a story of worry and hope at the same time.
Absolutely. But one last thing before we let you go is because there is rampant stress, people talk about it, work stress. How can we cope with stress better? And perhaps, 5 tips as a scientist.
Okay, so the easiest tip is sleep. Okay, that's the simplest, supremely simple tip, but it's one of the hardest to do. If you are, I would say maintain a sleep hygiene diary. Start with your sleep hygiene. Like you brush your teeth every day, twice a day. Like you have a routine of body rhythms that you follow, much the same way you need to clean up your sleep, which means shut off the clocks, shut off the lights, shut off the electronic devices, shut off all the noise, sleep. Go to sleep consciously. Don't kind of passively fall asleep while watching TV or on your phone or on a device. Genuinely tell yourself that first 10 minutes before you're actually going to practice sleep hygiene. And keep a sleep hygiene. A lot of these Fitbit apps and these other things and Apple Watch, whatever, those of us who have access to them can do that. If you don't have access, then you can write about it. But keep a sleep hygiene diary for a period of time, especially if you're under chronic stress. Make sleep hygiene a priority. So that's one. That'd be the number one, I would say. Number 2, I would say get out of wherever you are and go sit under a tree and walk on grass barefoot, and stare at the sky. Partly because it minimizes the scale of your problems when you look and realize that you are one human being on one tiny blue dot, which is only the, one tiny planet amongst galaxies and galaxies and galaxies. And for 2 seconds, when you allow that thought to seep in, you realize, my challenges may not be that monumental. Even when they feel like they're crushing you, for those 5 minutes at least, you can scale back and see it from a bigger picture. So I would say there is a reason why nurturing plants or gardening or walking outside or walking by a beach or staring at a sky or looking at a sunset can be so deeply takes you away from your own problems. I mean, these seem like what called whitewash level things, and they may not help when you are collapsing. Absolutely. But I think there are hygiene level things you can do to prevent things from reaching sometimes unbearable situations. I would say create a bunch of friends if you're lucky, where you can go and, I think friends buffer a ton of challenges more than one realizes. Have a set of good friends, be a good friend. Be there to listen to people when they are collapsing, because you pay back in that way to a broader world. It may not be the very same friend who listened to you, may pay it back to somebody else. You would be there to listen to somebody else, but pay it forward in a sense, right? In a sense, you're paying it forward. But I think being a good friend and having good friends is they are your natural therapy that occurs on a daily basis. So being able to talk about, then I would say the fourth thing is when the problem is insurmountable and it cannot be solved with quick fixes, ask for help. It's not a character flaw to seek therapy or to seek help or to seek pharmacological help when it's required. It's not a character flaw. In fact, it's a mark to me of great bravery to say, I have a problem and I think I need help. It's truly a hallmark indicator of profound bravery to ask for help when you need it. And so I would say, do not look around and feel intimidated by those who seem to view asking for help as a character flaw. It's not at all a character flaw. So that would be, to me, it's the hallmark indicator of the greatest bravery human beings can show, to say, I need the help, and then to ask for it. And so that's my fourth. And my fifth would be practice. I mean, self-care was the first two, right? Like, which is sleep hygiene and exercise. Yeah, exercise would be the fifth one. It can be in whatever format works for you. It doesn't have to be you don't have to go run a marathon. It might be a walk. It might be, it might be like just going in, gardening can be a form of exercise. Walking can be a form of exercise. Cooking, if you do all the chopping and cleaning and whatever, can be a form. But move your body and exercise, because exercise hits many of these pathways that allow you to promote resilience. And so it is a resilience promoting tool for sure. And it might be whatever. I mean, it can be your form of exercise, can be many different things. Exercise different things to different people. Unfortunately, you've narrowed it into a performance thing, right? Which is ridiculous. Then you're sad. Then you're, I didn't get this goal. And so now you're disappointed with your performance. It's not a performance thing. So if you remove the competitive element of exercise and just enjoy it, play a sport, walk, find friends, do whatever, I would say exercise is a huge player.
Making it a daily practice. And yes, actually, I think it is also about pushing yourself a little bit, completely by your sleep hygiene. And I think, it's amazing how many researchers, scientists, doctors have talked about sleep resolving so many health issues and also psychological issues, being around nature, creating a solid support system and asking for help. It sort of summarizes the steps that we can immediately start taking. The next time you feel overwhelmed with stress, remember, there may be lots more happening inside. Well, thank you very much, Professor Vaidya or Vidita, for joining in and giving us such useful and insightful information, something I'm sure I personally will never forget. Honestly.
Thanks so much, Shruti. I mean, I think it's, I work with rats and mice and I'm in my laboratory most of the time. And a lot of what I do sometimes has implications. Psychiatrists are far better placed to explain and understand this. But because I work with animal models and sometimes these insights are of value and use for humans as well. I feel that there are messages of outreach for all practicing scientists to take to the world outside, because their work has implications in a sense. And so thank you for providing me the opportunity to take some of these things out to a wider audience. And for me, it's always a profound learning curve, listening to other people, and listening to the questions you ask provoke me to think about work very differently. So it's a two-way street, because it's I was just literally thinking, and you asked me a really interesting question. You said, what was the most interesting and surprising thing to you about your work? And I was struck by the fact that perhaps the worry about what I found and the hope at the same time about what we find is what keeps us going, right? Because in some sense, I really feel like stress gets such a bad name, and yet you have such stress pathways are your survival tool, but you got to look after those pathways and not let them overwhelm you completely, because they can do a number. So yeah, thank you so much. This was wonderful.
This has been one of the best discussions that I've ever had on stress, because it's blown my mind. And I think discovering your early childhood experiences will go a long way in you figuring it out, what your coping mechanisms are and how you deal with stress and deal with it better. So thank you very much.
And you also, sometimes as parents, we forget, or as caregivers, those who are looking after younger generation, the manner in which we cope with stress imprints very heavily on those who watch us, because we are providing them the tools of how to handle difficult situations. So our ability to handle those situations is what they will model themselves on. These things get passed on. So in some sense, sometimes we think it's just us, but it's also having an impact on our local ecosystem quite deeply, especially children who are watching adults and how adults cope with stress. I mean, the world we are giving them is a terribly complex world, not an easy world that they are entering. We might as well at least do our level best to give them the tools to cope with the world that is out there.
Absolutely.